everybody, welcome back to another fun and exciting pre-calculus class. Today we are going to jump into lesson 5.5 that is found on page 85. 5.5, page 85. We're going to be talking today about horizontal and vertical translations and graphing by addition of ordinates. Actually, we're not going to do that last part. We're not going to talk about graphing by addition of ordinates. I'm going to let you kind of figure that one out if you want to. It's really kind of like an extra way to do this. It's like you could do it this way or you could do it this way. So I'm going to teach you the horizontal and vertical translation by just kind of the way that we've been doing it. And then if you want to, you can kind of go on from there. So let's jump into it. Go ahead and open your books to page number 85 and look what it says there. Horizontal and vertical translation. Well, what is this? Well, here's kind of what's going on. What's happening with horizontal and vertical translation is it's either it's like a rigid movement. It's not what is rigid? Rigid means it doesn't move, like it's not stretching it or compressing it. It's actually taking the entire graph and moving it to the left, moving it to the right, moving it up, moving it down. That's what's going on. So if you look down here at this graph, you're going to see a blue line. This is the original function. This is y equals sine of 2x. And then this red line here, okay, the secondary line, is the graphing of y equals sine of 2x minus pi over 3. What is that? Well, that's another translation. And again, what they've done is they've taken the entire graph and they've just moved it just a little bit to the right. All right. So how did that happen? Why did that happen? That's what we're going to talk about in this class. But it's called a horizontal translation, or they also call it a phase shift. All right, let's look at a couple things here on the screen. It says that the graph is shifted to the right or to the left when a value h, that's what this value is called. Remember we had the a value? What did the a value do? The a value was the one that either stretched it or compressed it, okay? And then the b value, we had that also in the last lesson. The b value is the one that basically stretched it out along the left and right, the x-axis. And so the A and the B are doing things, they're doing stretches, and that's what's called a non-rigid transformation. In other words, it's actually taking the line and stretching it out, whether it's up, whether it's compressing it. Now this transformation, this vertical and horizontal translation here, it's actually taking the entire thing and moving it. There's no stretching going on, there's no compressing going on. It's just an actual movement of the entire line, okay? So in other words, the line stays intact, it stays the same, nothing changes, it just moves to a different place. All right, so when the h is added to the x, that's what happens, or subtracted. All right, so if you look down here at this function of x equals sine of x plus pi over 3. Now, everything looks the same as the standard form except for this right here, this pi over 3. So what happens with this pi over 3 is you'll have one function, okay? And I know it's not great or anything, but, you know, deal with it. Now, what happens is, so this is the standard form. And what happens is, I'm going to draw it in a pink line, is it just moves it. And so everything is the same, it just moves it over. That's the only thing that's happened here. There's nothing, there's no stretching, there's no change. Everything's the same, except now it's moved over. In this case, it's moved over pi over 3 places, okay? Now, technically that was wrong. That was the wrong movement, and this one actually moves like this, okay? And I'll show you why. But it moves, this one right here actually moves to the left, not to the right. So let's talk about why it does that. Why is this one moving? Because it seems like, right, you're adding pi over 3. It should be moving to the right because we're adding. Well, maybe you remember parabolas. And when we had a formula that moved it to the right or to the left, it actually seemed like it was going the wrong way. Same thing is happening here. So what's going on? Let's look down here. Notice that the standard form for this is function of x equals sine times x minus h. Now this is the key right here, this minus sign, okay? Since the formula has a negative in front of the h, all h values change signs when inserted into the formula. So watch this. What is the h value here? Okay, you might say it's pi over 3. No, it's negative pi over 3. Okay, now watch. When I take this negative pi over 3 and I insert it into my formula, look what happens. I end up with x minus pi over 3. What happens in algebra when we have minus minus? Well, it becomes a plus. So it becomes x plus pi over 3. Okay, so that's very important to remember, and that's something that should be an Algebra 2 concept. You should have gotten that there when we dealt with parabolas. If you didn't, then make sure you get it here, because the negative in the formula, this negative right here in this formula, makes this turn positive, makes the negative h turn positive. So which way is this one going? It's going the direction of the h. The h is negative. And you say, no, it's positive. Look, no, it's negative, okay? Because the formula changes the sign. So it's negative, so the h pushes it to the left. This right here looks like it's going to the right, but you have to remember that negative sign is in the standard formula, so it changes the sign. Please remember that, very important. All right, one more thing about these horizontal translations, these movements left or right, is that sometimes there is a b value involved, okay? And what do you have to do if there's a b value? You need to factor it out first, okay? If you don't factor it out first, then you're going to have a problem. You're not going to be making your correct movements. So let's take a look at this right here. This function of x equals sine 2x plus pi over 3. What we need to do is we need to factor the 2 out of this. Okay? So when we do that, we get the function of x equals the sine 2 times x plus what? Well, that's the question. How did we factor the 2 out? What is factoring? Factoring is dividing, right? So how did we get that factored out? We did 2x divided by 2, and that cancels, and we have the x here, and this 2 that canceled comes outside, okay? So what we need to do is the same exact process with this pi over 3. Pi over 3 divided by 2, okay? And that's going to, whatever comes out there is going to go there, and then that 2 factors out to there. That's what's going on. So how would you do that? How would you solve this? Well, the way that I would do it is I would just kind of do it the way we've always divided fractions. Make sure that you flip it, change it to multiply. So we're going to change this to multiply, and then we flip the fraction so we get 1 over 2. 1 times pi is pi, and 3 times 2 is 6. So our new thing that's going to be there is pi over 6. So that would be pi over 6. You have to do that, or else you're going to think, oh, I need to move it pi over 3 places. And what is pi over 3 places? You might be thinking, I don't even know what that is. Well, let's kind of look at it on the graph. Remember, we have our x and our y coordinate, and then we've been dividing this line into what? Into pi, into 2 pi. Remember, because this is our degrees, 3 pi. And so this would fall, this would be shifted over pi over 6 places. Which way? Well, it's positive here, so that means our h equals negative pi over 6. So we're going to be shifting it to the left. How many spaces, how many positions? We're going to shift it over pi over 6 positions to the left. You might say, well, what does that look like? Well, if you break this up into 6 things, 1, 2, 3, 4, 5, 6, okay? So your graph would move over pi over 6 of those. And, the way that you would do that is just calculate what that equals. What does pi over 6 equal? You figure that out, and you figure out how much to move it over one way or the other. Okay, so how are we going to do this? Here's a little hack right here. This is the easiest way to do this. What you need to do is figure out what is your h, and then to shift the graph horizontally, okay, so going left or right, you are going to add your h to the key angle. What's the key angle? All right, let's jump back over here to the book. Remember, we're making our chart, right? So we're putting our key angle, we're figuring it out. If you don't remember how to do that, make sure to go back and watch one of the previous videos that I've done. So you're making your key angle here, and you're multiplying times 0 times 1/4 times 1/2 times 3/4 times 1. In other words, every little bit you're moving over to see where it's going to be on the y-axis. So what you do is once you calculate this, okay, so once you calculate all of these, notice right here, they're adding plus pi over 4. What is pi over 4? Well, go back here to this problem. So we're in example 1. That's page 85 still. Well, once they factored this out, they got, I know I got something different in the example I was doing on the screen. I got pi over 6. But here in this example, they get pi over 2. And they get negative pi over 2. So that changes to positive pi over 2. So the translation or the movement left or right is going to be going to the right positive pi over 2 places. Well, how does that or pi over 4 places? How does that happen? Well, you just add pi over 4. So figure out your key angle, add pi over 4. Figure out your key angle, add pi over 4. Figure out your key angle, add pi over 4. Now, one of the tricks here is that you do have to have common denominators. So if you're not coming up with a common denominator, just make sure you have a common denominator before you try to add. Like, look right here. We can't add 1/2 plus 1/4. That doesn't work. So we had to take our common denominator to 4. Right here, they actually have the common denominator of 4, but then they're going to reduce it because look, they got 2 pi. This comes out to 2 pi over 4, and then they reduce that to pi over 2. So make sure that you're following your fraction rules. It's very important to remember your fractional rules, and then just, execute those the way that you know to do it. Reduce when you need to reduce, get an LCD when you need to find your LCD, and that's how you get your key angles, okay? Not real hard. Once you kind of know how it works. Once you know how to get the key angle, you're just going to add or potentially subtract your h. So this pi over 4 is your h. This is being added or subtracted to your key angle, okay? The next thing that I want to show you is on the next page. What about when we're doing a vertical translation? Vertical translation. Look at the helpful hint. It tells you that when k is greater than 0, so when k is positive, it's going to shift up. Now this one does not have, look, here's the standard form, k plus. So k is positive in this one. So this one reacts just the way k did when we were doing parabolas. It goes up when it seems like it should go up. It goes down when it seems like it should go down. It's different than the h goes kind of opposite of what you think, and here the k goes the way that you think that it should go. So be careful on those two. They're a little different. So just make sure that you're paying attention. So let's look down here at this screen and let's talk about where does the k go? Where do we put it? How do we make this happen? All right, right here is our standard form. The function of x equals k plus the sine of x. Remember that this k right here is positive, so it's going to react the way that you think it's going to react. When k is positive, it shifts up, and when it is negative, it shifts down. This is accomplished by simply adding k to the key point. Let's jump back over here to your book. We're on page number 85 now. Look what happens when we graph this. Function equals 3 plus 2x. Our 3 is being added to the key point. What does that mean? What's our key point? That's our up and down. Our key point is our up and down. Remember, that's our y coordinate. And so if we take that 3 in this case, this is like super easy right here. It really is. If you have a positive 3, which is what we have, look at what we do to the key point. Every key point, we just add 3. That's it. So what's the hard part here? The hard part is remembering how to find your key point. That's the video you need to go back and watch if you're struggling. This is just adding 3 to the key point. Look, here's the next key point, 0 plus 3. The next one was negative 1, add 3. Okay, and so on. In every key point, you just add 3. Now, what happens if it's negative 3? What happens if this is y equals negative 3 plus cosine? Then we would subtract 3. What happens if it's plus 1/2? We would add 1/2. Okay, whatever the number is here, you just add it to your key point. It's really and truly that simple. All right, so what happens once we do this? Notice what happens. We took this line. This line should be down here, right, along the x-axis. This is where the standard form line is. But look what happened when we added 3. We take it and we add 3 to everyone, and it bounces it up 3 spots. So instead of being here along the x-axis, it's 1, 2, 3, and it's right here along number 3. So your amplitude is still 1. So the k does not change your amplitude. Your amplitude stays the same, okay? What the k does is it takes the entire line and it moves it up or it moves it down. It does not stretch or compress the graph. The graph stays stationary. Now, can you have an A, a B, a K, and an H in the same problem? Yes, you can. It can be doing all kinds of different things, stretching, compressing, translating up, translating over. It can be doing all those things at the same time. But you have to understand what each thing is doing. The A, the B from the last lesson, and now in this lesson, the H and the K. They're all making different movements. I'm not going to take the time to do one of these problems because I feel like it's really all you have to do is add. Just add it to the key point and add it to the key angle. Okay, so what are we adding to the key angle? We're adding our H. What are we adding to the key point? We're adding our K. You do that, and that will just move your graph up, down, left, and right. Okay? Hope you learned something there. If you missed anything, make sure to slide it back, watch it again, okay? We'll see you later. Have a good one. Bye-bye.